going to continue on with that. The only difference here is the triangles are going to be formed by different things, specific things. And some of those things are things that we've talked about as we've gone throughout the year. As I look up here, perpendicular and angle bisector. So perpendicular on this one here, for instance, means that this makes a right angle. And one of the things that we're going to talk about here is if this is the perpendicular bisector of this, and we know that it is because these two pieces are congruent. They're both 4 and 4. Then that means these two would be congruent as well. Okay? So the piece on the right-hand side would simply just be x equals 5. Any point that's on this perpendicular bisector would be equidistant to any point that's on that segment. Okay? Not just the bisecting part, but any other part as well. This one's essentially the same thing, except it's turned sideways. And it is the bisector again. Now this one is what we call an angle bisector. Because these two angles are the same, then that means this is bisecting it, and we know both of these are 90. Okay? So, once again, very similar to what we talked about in the last one. These two pieces are going to be congruent to one another. The only difference on this one is that we have an expression. We have x plus 7, and that is going to be equal to 15. And then we subtract 7, and we get x equals 8. Okay. So on that one, we're trying to find out what the value of x would be to make those two the same. As we've seen throughout the year, we got to really be careful of the question that's being asked. Are they asking me what is x? Or are they asking me what is the length? We have to figure out exactly what it is that we're trying to find. Hey, and that's kind of what we're talking about down here. A line that is perpendicular to a segment. So in this case, CP is the perpendicular bisector of AB. And we know that because it tells me that, and it's also marked on the picture. So, as we saw like in our triangle proofs, sometimes it's marked, sometimes it's a statement, sometimes it's both. We can do it either way. Here, if I look at the picture, I know these two pieces are congruent on this segment. I know this is perpendicular. So I know P is right in the middle of this segment. P is that midpoint. Okay? Now, this is a line, right? So we don't necessarily know like if this piece is congruent to a piece down here. All that we're telling is that piece right there. But what we can do here is if I connect C to those two endpoints, then we also know C to A is equal to C to B. So I can draw that segment in. And I could do that for any point that falls on this line. Okay, it doesn't have to be C. I could put a point like D right here, and I could draw D into A and B, and that would be equidistant. Okay, this one's called the perpendicular bisector theorem. Once again, CP is perpendicular to AB, and it's also bisecting it. So if a point lies on the perpendicular bisector, if C lies on that line, then we know that C lies on the perpendicular bisector. And we know these two pieces are congruent. So once again, we can say CA equals CB. Okay, and we're using all the same things here. So now if I use the converse, this line does not extend all the way through D. But if I were to keep extending that line and continue on through D, then what I notice is D to B and D to A are the same length, right? So because these two are the same length, then what I can conclude here is that D lies on the perpendicular bisector. Because dA is equal to dB. So I just extend that on, okay? I extend it through, and we know these two are equal because they're marked equal. We're not guessing that they're equal, they're identified as equal, okay? If they weren't marked as equal, then we wouldn't be able to determine if they're equal or not, okay? So we know this is the perpendicular bisector once again because these two are congruent, but we're not always going to be given that. What it's going to look like in other situations is it might look like this. And I might put a point like right here. And I might say, is A on the perpendicular bisector of that segment, let's call this RS. And we would say yes, because if these two pieces are congruent, then A would have to be equidistant from R and S, and it also has to be perpendicular to RS, okay? So this part right here may not be marked already. This one here it is because it's just showing what the theorem does. If D is on this here, then we know it forms a 90, and we know that it's going to split it in half. It's going to bisect it. Okay, so we're going to use all those theorems. We're going to do a lot of different things with it. I know this picture's kind of hard to see. There's a red outline here, which is what we're looking at. And I'm going to zoom in a little bit here, just so we can see it a little bit better. I can see that KL and I can see that LM are congruent. So we have this picture here. And I'm going to redraw it a little bit differently than maybe what it is in the picture. This is K, this is L, and this is M, and this is N down here. All that we know right now is these two are congruent. We're wanting to know, is there enough information to conclude that N lies on the perpendicular bisector? Okay, so right now we know it's a bisector. Is it the perpendicular bisector? What else would we need to know? What would we need right here? We need 90-degree angles, right? We need a 90-degree angle here. We don't know if it's perpendicular, okay? And the reason I draw it like this is because could these two pieces still be congruent and it still not be necessarily a 90-degree angle? I could have an obtuse angle here and an acute angle here, and those two could be congruent. As what always happens here, when I look at this originally, this looks like it could form a 90-degree angle, right? Looks can be kind of deceiving sometimes. So we can't go off of looks. Even though that looks to be a 90-degree angle, we can't just say, yeah, it looks like it must be 90, okay? We have to go off of what we know. All we know right now is that it's bisecting. L is bisecting it, NL is bisecting it because it splits it in half. We don't know if it's perpendicular, okay? So that's where we got to be careful here. If I had a 90-degree marking, then we would be okay, but we don't. Okay, down here. Is ZX the perpendicular bisector of WY? What information do we have right now that's marked? We have a right angle, right? We have a perpendicular angle. We know that ZX is perpendicular to WY. Does it also bisect it? Is it the bisector of it as well? Do we know right now that WX and XY are congruent? No. Does it look like they could be? Yeah, probably, okay? But we can't prove it. There's no way to prove that right now, okay? And so all that we know right now is that ZX is perpendicular to WY. We don't know if it bisects. So we would say no. The question said, is there enough information to conclude that is the perpendicular bisector? Okay, so in order to be a perpendicular bisector, two things must be true. It must be perpendicular and it must be bisecting it. It has to fit both of those. Okay, so it can't just be perpendicular and it can't just bisect. Up here it bisected it. This one is perpendicular. We got to have a combination of the two. We got to have both pieces to know it's the perpendicular bisector. All right, just when we think we're done with proofs, here's another proof, right? Everybody's favorite. Okay, it says write a 2-column proof to identify or show that LP is equal to LQ. Okay, up here it says point M is the midpoint of PQ. LM is the perpendicular bisector of PQ. So I'm going to put that into a given statement. I'm going to say PM is congruent to QM. And I'm also going to say LM is perpendicular to PQ. Okay, what we're trying to prove here is that these two pieces are congruent, LP and LQ. If there's no symbol above LP and LQ, what are we trying to prove here? What does it mean when I have LP without a symbol above it? What does that mean, LP? It's distance, right? We're saying what is the distance from L to P? So what we're essentially saying here is the distance from L to P is the same as the distance from L to Q. We're not saying segment LP is congruent to segment LQ. There's no segment symbol above it. We're saying the distance from L to P is the same as the distance from L to Q. And we know this is going to be our final statement, because what we're trying to prove is always our final statement, okay? So just trying to think about how we can get there. Well, do we know right now, yeah, you need to do that like passive period, okay? But you can go ahead. Right now, are those two triangles congruent? How many pieces do we need to prove that those two triangles are congruent? We need 3, right? This goes back to last chapter. Right now, do we have 3 marked? No. We have 2, right? We have a side and we have an angle. What would be another piece that I could use? Used it over and over and over again last chapter. Yeah. LM is congruent to LM. That side, that piece is shared by both of those triangles. And what's our reasoning for that always? Reflexive property. Okay. So now, are those two triangles congruent? Yeah, what theorem, what property can we use? Side angle side, right? It's another reason why we got to have good understanding of these proofs, guys. They're not going away, right? We're not going to see them the rest of the year, but we're going to see some of these things. And that's what I told you about geometry from the beginning of the year till now. Everything that we use from the beginning of the year is still going to show up time to time. Okay, now this is a little bit more recent, but we sometimes still see supplementary angles, we see complementary angles, we see midpoint and distance and some of those things. Those are things that are just going to continue to pop up. And it's just a big continuous. You never know when we're going to see some of those things. So we're going to say triangle LPM is congruent to triangle. Okay, the triangle on the right, L is going to match with L, yep. P is going to match with Q, and then M matches with M. And we said that's true because of side angle side. Okay, so if the two triangles are congruent, what do we know about all the pieces of those two triangles? What could I say about angle P and angle Q? They're the same. How come, Xander? Okay, and so what theorem did we use that we could use there? What'd you say? Okay, not yet. Yeah, there you go. CPCTC, right? Because if we know the two triangles are congruent, then all the parts of those two triangles are congruent. Okay, so here's what we're going to say. The piece that we want to prove is these two pieces right here, LP and LQ. But I'm going to show you how we're going to do that, because this is a little bit different. We're going to say those two segments are congruent because of the CPCTC. If my triangles are congruent, all the sides are congruent. Is that my final statement? No, because what are we trying to prove? We're trying to prove LP, the distance from L to P, is the same as the distance from L to Q. Oops, I don't want segments above both of those. LP equals LQ. What would we say there? If two segments are congruent, then what do we know about their length? They're the same, right? If I said these two segments are congruent, if this one's 3, the other one's got to be 3, right? If I'm just making up a number, and we call that the definition of congruency. If two things are congruent, they're equal. If two things are equal, they're congruent. You can say it either way. Okay? So you got to be careful about what it is we're trying to prove. This does not have a segment above it, so we're not proving a piece, we're proving a distance. Okay, on this page, a lot of these are pretty straightforward, but you have to pay attention to what we're given and what we know and what we're trying to find. Okay, on this one here, SQ. What can we say about SQ in this case? SQ is what? Perpendicular bisector, right? We know it's perpendicular because we have a 90-degree angle. We know it's bisecting because these two pieces are congruent. So we know that SQ is the perpendicular bisector. They don't come out and say that, right? There's no statement that says SQ is the perpendicular bisector. We're getting all that information based on the markings that we have. Okay? So once we know that SQ is the perpendicular bisector, we know these two are congruent. What would I say about SP? What would SP? What could we do with SP? What did we say earlier? If SP is 6.8, and I want to figure out what RS is, this piece right here, what would we know about those two segments? It'd be 6.8, okay? We know these two are congruent, okay? So all we have to do here is say RS is 6.8. They're the same. The distance from P to Q is the same as the distance from R to Q. So therefore, we also know the distance from P to S is the same as the distance from R to S. As long as it's on the perpendicular bisector. As long as S is on that perpendicular bisector. Okay, on this one here, we know this one is perpendicular, right? We don't know immediately if this is the bisector, but what two pieces do we know are congruent? Okay, GH and EH, right? Those two are congruent. They're given to us. 24 and 24, they're congruent, right? So that means it's perpendicular. We know H to G and H to GE is the same length. So what can we say about G to F and E to F? They're the same, okay? So what do you think E to F is going to be? 9.5. Okay, that's why I'm telling you a lot of these are pretty straightforward. Now, if I asked you to find the length of E to G, what would I do to find this whole length right here? Just add them up. 9.5 times 9.5, or 9.5 plus 9.5, or 9.5 times 2. Okay, either one of those would work. Okay, this one here is the same idea, except we don't have just actual numbers, we have expressions. But once again, is BD the perpendicular bisector? Okay, and we know that because, first up, what do we see? What's this tell me? 90, it's perpendicular, okay? And we also know that this is congruent, right? So we know B is the halfway point of CA. So it's bisected, it's split in half. So we know that DB is the perpendicular bisector of CA. That's what everything is about today. It has to be the perpendicular bisector. It has to be perpendicular and it has to bisect, okay? We know that's true here. So we know that these two pieces are congruent. Because it's on the perpendicular bisector and D is on the perpendicular bisector, I can do 3x plus 14 equals 5x. Now this is where you got to be a little bit careful. Okay, the question doesn't say find x, it says find AD. So once we find x, we got to plug it back in and we got to find AD. So we're going to subtract 3x from both sides and divide by 2. We get x equals 7. Okay, 7 is not our answer. A lot of times, like on a big ideas question, people will put 7 in and be like, I think I did all my math right, Mr. Rood, but it's not counting it right. 7's not what it's asking. It doesn't say find x, it says find AD. Here's AD, x is 7, so 5 times 7 would be 35. What would the length of CD be? 35. Yeah, it's the same thing, right? And I could plug it in here. 7 times 3 is 21, plus 14 is 35. Okay, just to double check that those two are congruent, but those two should be the same length, okay, because we said they're equal. Okay, this one comes right out and says ZX is the perpendicular bisector of WY. It doesn't have it marked on the picture, so that would be the first thing that I would do. It tells me it's the perpendicular bisector. It already has the 90-degree angle marked, but it doesn't have the congruent markings marked, okay? So we're going to mark those two congruent. We've got 90-degree angle. What other pieces would also be congruent? Landon, let's put our phone away. What other pieces would also be congruent? ZX is congruent to itself, right? That's the reflexive property, okay? But if Z is on the perpendicular bisector, what other pieces could we mark as congruent? ZW and ZY, okay? So we also know these two are congruent, okay? And I'm just going through and marking pieces that we know to be congruent. So it says here, find WZ. Right now we know YZ is 13.75. So we know this is 13.75. And I want to find WZ. But now once these are marked, how easy is this, right? If this is 13.5 or 13.75, what's this guy over here going to be? 13.75, right? We don't have to make this too hard today. But we do need to understand why and how. Okay? We can't just look at a number and say, oh, it's just going to always be 13.75. We got to pay attention to the pieces that we have. Do we have enough to get there? Okay, this is essentially the same picture. ZX is the perpendicular bisector of WY. So once again, mark everything on your picture. It may not always be the exact same picture. We know those two pieces are congruent. We know these two pieces are congruent. It gives me WZ and YZ. Well, we just talked about this. WZ and YZ are equal. So I can make a statement and I can say WZ equals YZ. And then it gives me an expression, WZ is 4n minus 13. YZ is n plus 17. Now we just got to solve for n. Okay, what are we going to do first to solve for n here? What do you think, Ethan? What would I do first to solve here?
Subtract or add 13.
Okay, that'd be fine. Yeah. You got some different options you could do here. Add 13 would be good. Okay. And if I move my numbers to the right, I got to move my n's to the left. So what am I going to do with the n? Right now it's a positive 1n. What are we going to do to bring this over here? Subtract it. So minus n. And you can do all that in one step. You don't have to do like two separate steps. It's the way you probably started doing it like back in algebra, but we don't need to separate two separate steps anymore. And then divide by 3, and we get n equals 10. Okay, what does the question ask us to find? Find YZ, right? Right here, find YZ. YZ is n plus 17. We now know the value of n is 10, so 10 plus 17 is 27. Okay, this one is the same picture, but the problem starts all over again. Okay, right now, do we know that ZX is the perpendicular bisector of WY? Based on what we have right here, based on the markings we have, is ZX the perpendicular bisector? We don't know, right? What's the only thing that we do know?
90 degrees.
It's 90 degrees. So we know it's perpendicular, but we don't know if it's bisecting. That's where it gets a little bit tricky because it is the same picture and you're like, well, it was here, so it is again here. We're starting a completely new problem here, guys, okay? So we can't just take the information from the last problem and use it here, even though it is the same picture, okay? We're going to have new information. Just because it's 27 here doesn't mean it's 27 here, right? This is a completely new problem. So we just wipe the slate clean and we say, okay, let's start over now. We know ZX is perpendicular to WY, and that's all that we know. Then it also gives me some pieces here. So WZ is 20.5. WY is 14.8. What I like to do there is I like to just show from W to Y is 14.8. YZ is 20.5. Okay, so let's think about what we know. We know it's perpendicular. Okay, what other piece of information is critical right now? What do we notice? Do we have two pieces that are congruent? Durston? Hustle. You guys need to start. You were just in there during passing period with me.
Yeah, no, we're not again.
Okay? What do we know right now, looking at this? What two pieces are congruent?
The perpendicular angles and the 20.5.
Yep, the 20.5 sides, right? So by that information, either I can tell you that these two pieces are congruent, or I can tell you that these two pieces are congruent. If I have a 90-degree angle, then it is the perpendicular bisector. The distance from Z to Y is the same as Z to W, or the distance from Y to X is the same as W to X, okay? So therefore, if I know these two are congruent, what can I say about WX and XY? What do you think, Ben? What would I say about WX and XY? They're the same, okay? These two are the same because these two are the same, right? Now, what we know is that WY is 14.8. So if I wanted to find out what WX and XY is, and I know that entire length, then what could I do to find what that is going to be?
About 14.8.
14.8 divided by 2. Because we know those two pieces are equal. And so then that would be 7.4. So both WX and XY would be 7.4. All right, that is 6-1 day 1. Tomorrow we're going to continue with a lot of this kind of same stuff. We're just going to kind of go different directions with it.